part 2. And with part 2 of this discussion, we're going to be looking at valence electrons and forming ions. So yesterday, you guys worked through part B, looked at that table, looked at valence electrons. Today, we're just going to make sure that we have all the information correct, and that we label the periodic table with the valence electrons and the ions that are formed. So, to start, we're going to talk about valence electrons. So, valence electrons are what we would call the outermost electrons. Now, we'll look at these outermost electrons and what it looks like when we look at bonding. But the most important thing with valence electrons is that these are the ones that are involved with bonding. Valence electrons are what determine how something reacts. So those alkali metals, we looked at the video of those reacting with water. Alkali metals are explosive with water. Everything in group 1 is similar because it's in the same family, and that's because of the number of valence electrons that they have. Here's the biggest thing, and I put it in red on the slide. Atoms want 8 valence electrons. And so they will gain or lose to get to 8 or 0. Because 0 valence electrons is going to be like 8 valence electrons. So when we're looking at valence electrons, we're looking at, will it get to 0 or 8? Now, whichever one it's closest to is the number we're going to go to. So we always ask, is 2 closer to 0 or 8? And that's going to help us determine the ion and the charge. And so what we're going to do is we're going to start by labeling the periodic table. So we're going to label both of these periodic tables. So we're going to label the colorful one first. Then we'll go back and we'll label your green periodic table. I'm going to get a Sharpie so that you can see it. And so yesterday in part B, we looked at how to determine the number of valence electrons, and it's based on the group that it's in. Now we have 2 parts of the periodic table. We have what are called the main group elements, and then we have the outer elements. The main group elements, if you look on your colorful periodic table, the main group elements are the ones that end in A. 1A, 2A, we skip the entire middle, 3A, 4A, 5A, 6A, 7A, and 8A. And so the valence electrons are based on that number. So here's how we're going to label this. I'm going to label 1 VE for valence electron over group 1. Over group 2, I'm going to label 2 valence electrons. Then we skip the entire middle part. So you'll hear me a lot of times count 1, 2, skip a few. I'm skipping that middle part. Then we come over to 3A. 3A has 3 valence electrons. 4A has 4 valence electrons. 5A has 5, 6, 7, and 8. So we go 1, 2, we skip the entire middle. 3, 4, 5, 6, 7, 8. That's how many valence electrons each of those families have. We skip the middle, because transition metals are a little bit different. So now let's do the same thing with your green periodic table. Because again, your green periodic table you're going to be using a lot. Once we're done learning about the periodic table, it's this green periodic table that you're going to be using a lot during class. So we'll do the same thing. I'll label 1 VE for valence electron, 2 VE for valence electron. All right, so we go 1, 2, skip a few. Skip the entire dip of the periodic table. Above boron, that's 3. Above carbon, that's 4 valence electrons. Nitrogen is 5. Oxygen is 6. Fluorine is 7. above helium, the noble gases are 8. So the families have between 1 and 8 valence electrons. So when something asks how many valence electrons does this element have, your number should be between 1 and 8. If you write down 12, it's probably not right because your number should be between 1 and 8. So we've labeled valence electrons on both of these periodic tables. Again, the reason that I'm labeling on the green periodic table here is so that when we start just using the green one, you have everything labeled on here. And you could always go from the colored periodic table and transfer it over to the green one as well. And so, oh yeah, we labeled the periodic table. Now what we're going to do is we're going to look at how valence electrons cause charges. So ions are charged particles. We will start to look a lot at ions. We're going to do some naming. So these charged particles are formed by gaining or losing electrons. When we look at something with charges, it's always about changing the number of electrons. So when we looked at isotopes, it was about changing neutrons. Now it's about changing electrons. You can't change the number of protons because remember, protons is atomic number, and you'd be changing the element. And so we're going to actually look at how to determine the charge. Now I have here, we do protons minus electrons, but I'm going to show you an easy way to figure out what the charge is. Always just remember, protons are positive and electrons are negative. And so we're always going to compare the two. We're going to compare protons to electrons, and we're going to see what the charge is. We'll look at some examples. But before we look at some examples, what I want to do is I want to go through again and label the periodic table with the charge, right, with the charge that each family would create. And so here's what we're going to look at. I might put it on the bottom just to keep them separate. We need to ask ourselves, is the number of valence electrons closer to 0 or 8? So, the alkali metals, group 1 has 1 valence electron. Is 1 closer to 0 or 8? 0. So that means that group 1 is going to lose 1 electron. Electrons are negative. If you lose a negative, it becomes positive. So group 1 will form ions with a +1 charge. So whenever the alkali metals react, they form a +1 charge. Then we go through 2 valence electrons, closer to 0 or 8. 0. So now you have 2 negatives. Right? 2 negatives, 2 electrons. Electrons are negative. If you lose them, well, now it's +2. So now the alkaline earth metals form ions with a +2 charge. All right, we're skipping the middle. We're skipping the entire middle. We don't worry about transition metals or the lanthanide or actinide series. You might be able to see the pattern here, right? +1, +2. So group 3 is going to form charge of +3. And then we get to 4. Is 4 closer to 0 or 8? Right in the middle. And so what we're actually going to write underneath group 4 is plus or minus 4. That plus or minus depends on if you're looking at metals or nonmetals in group 4. Group 4 consists of carbon, silicon, germanium, tin, lead. Some of those are metals, some of those are nonmetals. Metals are positive, nonmetals are negative. Then we get to 5 valence electrons. Well, if 5, you ask yourself, is it closer to 0 or 8? It's closer to 8. And so if we want to get to 8 valence electrons, everything wants to be like a noble gas. So if we want to get to 8 valence electrons, we need to add 3 electrons. Electrons are negative. So you add 3 electrons, you're adding 3 negatives. So group 5, nitrogen's family, will form a charge of -3. Oxygen's family will form a charge of -2. The halogens will be -1. And the noble gases already have 8 valence electrons. They have a full outer level. They're not going to form a charge. They don't react. So if you take a look at this, it's +1, +2, skip, +3, plus or -4, -3, -2, -1, 0. So those are the charges that each of the elements form when they react. And so that'll be useful as we look at naming, right, looking at ions. And you could do the same thing on your green periodic table. And I could write all of my pluses or minuses above the valence electrons. So +1, +2, skip the middle, +3, plus or -4, -3, -2, -1, and 0. So if it asks what charge does chlorine form, well, you find chlorine on the periodic table. Chlorine forms a -1 charge. So that's looking at labeling our periodic table, looking at valence electrons. And so what we're going to do is we're going to actually look at some examples. So before we get into the examples, I need to put this down. I'm going to write on the board with this. All right. We have different types of ions. So in case you see the word cation, right, like a cation, that's a positively charged ion. So think about the T looks like a plus. Cations are positive. Those are metals, right? Metals tend to lose electrons. Electrons are negative, so they become positive ions. Anions are negatively charged. These are your nonmetals. So we talked about the periodic table and characteristics of metals and nonmetals. That ties into ions as well. So let's look at some examples. So we're going to do some of these together. I'll have you do some with your groups. And this is another reason that I gave you the slides so you can write directly on here. So this says determine the ion with symbol and charge. For each of these examples, label if it's a cation or anion. So this is going to have us go back and review a couple things. Notice that they give us protons and electrons. When we talked about isotopes, we talked about how protons and electrons were equal because it was a neutral atom. Ions are not neutral, they have a charge. So let's start by focusing on protons. Something I want you to keep in mind that we talked about before. Remember that protons are the same as the atomic number. So when they give us the number of protons, that gives us the atomic number, which tells us what the element is. Remember on your green periodic table, right, the atomic number is that big number right above the symbol. So in number 1, it says we have 3 protons and 2 electrons. So I'm going to start by figuring out what element this is. 3 protons means an atomic number of 3. So if I look at the periodic table, lithium has an atomic number of 3. So my symbol is Li. Now when it says to also look at the charge, right? Protons are positive. Electrons are negative. Just compare your positives to negatives. You have 3 positives and 2 negatives. You have 1 extra positive. So this is Li plus 1. When you're looking at the charge, just compare your positives to your negatives. And then since this is plus, remember a cation is a positive ion, an anion is a negative ion. So since this is Li plus, we would say this is a cation. Any positive ion is a cation. If we look at number 2, 9 protons and 10 electrons. So remember, your protons tell you the element. That's the atomic number. So look at your green periodic table. Atomic number of 9 is fluorine. Right, atomic number of 9 is fluorine. That's right off the periodic table. There are 9 protons and 10 electrons. You have more positives or more negatives?
More negatives.
More negatives, right? You have one more negative. So we'd say it's -1. And then since this is a negative ion, this is called an anion. So see if you can go through 3 through 6. All right, you want to talk to people around you, that's fine. But work through questions 3 through 6. You're going to do just like what we did up here. Find the symbol and then figure out, do you have more positives or more negatives? And how many more? That's your charge. While you work through it, I'll go through each one, right, little by little, so you can check answers as well. If you're not sure of the charge, at least find the symbol for each one of these. Use the number of protons to figure out the symbol. So if you check your answers for 3 through 6, remember the number of protons is the atomic number. So what I did first is I went through each of these and I determined the symbol. Just look for the atomic number. You find that right off the periodic table. And then the charge for each one, because these are not equal, that means it has a charge. If number 3 was 11 protons and 11 electrons, your positives and your negatives equal, that'd be neutral. There'd be no charge. But because you have one more positive than negative, it's +1. Positive ions or cations. All right, number 4 is Mg. There's 2 more positives than negatives, so it's Mg +2. 5, you have 2 more negatives, so it's S -2. And then in 6, you have 3 more positives than negatives, so it's Fe +3. So this is just looking at the ion by comparing protons to electrons, but also remembering that protons are the same as the atomic number. And so the last set of examples that we're going to do, and then you'll be able to work through some of the practice with your groups. Should be able to get through it then, and you won't have any homework for tonight. So the last thing is it says determine the number of protons and electrons in each of these. So determine the number of protons and electrons in each of these ions. Remember, protons is the atomic number. So what I want you to do is look at your periodic table and find calcium. Okay, look at your periodic table and find calcium. What is the atomic number of calcium? 20. So calcium always has 20 protons, no matter what. Now the electrons depend on this charge. If it's Ca2+, that's the same as +2. 2 plus and +2 are the same thing. This means you have 2 more positives. That means I should have 2 more protons than electrons. So I'd have 18 electrons. Your number of protons should not change if it's calcium. You change your number of electrons. Okay, see if you can go through and do the same thing for sulfur and nitrogen. Figure out your number of protons. That's based on your element, right, based on your atomic number. And figure out your electrons. your electrons is based on the charge, whether you have more positives or more negatives. So S2 minus, your protons is 16 because that's the atomic number. 2 minus, or minus 2, it's the same thing. That means you have 2 more negatives. So there's 18 electrons. And then number 3, protons is 7 because that's the atomic number of nitrogen. 3 minus means you have 3 more negatives. So you have 7 protons and 10 electrons. Any questions on the examples? No. All right, so for the rest of class, I'll just put this up so you can see. So we went through the discussion. So you have the slides. At the end of the packet we were working through yesterday, I say packet, it's 2 pages. The very last page says practice problems. There are 6 questions. For the rest of the time, you should be able to get this done in the next 12 minutes. Work through these practice problems. Again, this is what it looks like, it says practice problems. Whatever you don't get done in class, that's your homework. The very last page of that discussion, the slides, says ions at the top. We're going to work through that tomorrow. And so you'll work through these practice problems. I'll put the answers up here. Like always, you're more than welcome to come up and take pictures. But just work through page 3 of the discussion packet, right, with the